Hello friends, today we are going to discuss about the data structures in Python. Now, as we all know about the data structures, it is a way to organize the data in such a way so that we are able to access it efficiently. Now, we have the four types of data structures in Python that are lists, tuples, dictionaries, and sets. So today we are going to discuss about the lists. Now, what are the lists? Lists are the ordered collection of objects. Okay. Now, lists are heterogeneous in nature. Means we are able to store the data inside the list of any type. And it can grow or shrink in demand. Means we are able to add the elements according to the user's need or delete accordingly. There is no need to declare the size of the list. Okay, we don't need to declare how many elements we are going to store inside the list. There is a point that it is an ordered collection of objects. What do you understand by this line? That is the main point to understand inside the list. Okay. It is of heterogeneous in nature, means we are able to store the data of any type. Now, let's store the data. Okay, we have the L1 list. Now, I have the data 135, suppose it is already written here, 135 start, okay, and 9. This is the data stored inside the list. Now, it is an ordered collection of objects, means this object is stored at the first position. This object is stored at the last position. Okay. Now, it is in this order only. The objects are stored in this order. So, we are going to access them in this order, means according to the index where they have stored inside the list. Okay. Now, what is the index of 1? It always starts from 0. The index of 1 is 0th. What is the index of 3? That is 1. Index of 5 is 2. Index of start is 3. Index of 9 is 4th. Okay. So the objects are stored in this manner. That is called the ordered collection of objects. Okay. Now, next is there are many methods which we are able to use inside the list. First is append. Now, what append function does? It is used to add a single element inside a list. If you want to add a single element inside the list, we are able to use append. Okay. Now, what happened if we use append function? It adds an element at the end of the list. At the end of the list. It adds a single element, but at the end of the list. Now, let's see how the append function works. Now, here we have this list. Okay. Now, I'm going to use the append function. Now, let's add some object. For example, I'm going to add 10. Okay. Now, we have a list L dot append. Going to add the number 10. Let's print the list. Let's execute the file. Now you can see the 10 is added at the end of the list. Okay. Now let's move ahead. Now we have the function extend. Now what extend does? It is used to add all the elements of another list to the end of the list. Okay, means if you want to add these all elements inside the list, inside the list, then we are able to add, okay, the whole elements and make one common list, right? Now let's see how do we add. Let's make one more list which stores element, and let's add by using the extend function. Let's print. Execute the file. Now you can see we are able to add all the elements of one list to the another list. Okay. Now here there is an insert function. Now we have already studied about the append, where we are able to add a single element inside the list, but the position is at the end. But if you want to add an element at any position inside the list, okay, if you want to add at the second position, fourth position, fifth position, you can able to add with the help of the insert function. Here, the insert function takes two arguments. First is the index, where you are going to store that particular element. Okay, here I want to store O at the third position, at the third index. Okay, now let's write the code in the pie chart. Insert an element, l.insert. Let's insert at the third position only. Add. Okay. Print. You can see we have added open at the third index. Third index is it starts from 0, 1, 2, 3. Now at the third index we have an element that is open. Okay. Now next is we have the function that is index. Now what index is? That describes the position of an element. Okay. Now we have an element and we want to know its position inside the list. Okay, we want to know its position inside the list. Then we are going to use the index function. Okay. Now let's write the code inside the pie chart. Let's take one variable d and the list name is l.index. I want to find out the word open. Okay. I want to find out the word open. Now print d. See the index of that particular word. That is 3. Right? We have stored open at the third position. And if we want to find out where it has stored, that is at third position. Now next. That is length, which is used to find the length of the list. Let's write the code. Let's take in variable f, use the length function. Now let's print the length of the list. Length of the list is 12. Okay. Now next functions are sum, min, and mix. Now these functions are going to apply on the integer elements only. Okay, we can't apply on the heterogeneous list. For that purpose, I'm going to make one homogeneous list. Okay, L2 which stores 13.29. Right. Now let's take the sum of all the elements present in L2. Print sum function, then L2. Now you are able to print the maximum number and minimum number in the same. Mix just L2. Similarly, the minimum number, min L2. Okay. Now, as we all know about the sum, max min, right? Now let's execute. Now what is the sum? That is 142, which is the maximum element, 120, which is the minimum element, that is 9. Okay. Now next is the sorting. If you want to do the sorting inside the list. Now in the same manner, sorting is also performed only on the homogeneous elements. Okay, please note it down. Right, homogeneous elements. Now we want to perform the sorting. There is a sort method. By default, it works as an ascending order. If you write reverse equal to true, then it gives you the order in descending. Okay. Now let's write the code inside the pie chart. Now we have the homogeneous elements stored inside L2. Now let's sort them. L2 dot sort and L2. Now let's see what's the output. It should be in descending, should be in ascending order, not descending, right? Ascending order 9, 30, 120. Now how it becomes a descending order? If you are going to write it here as reverse equal to true. Now it becomes the descending order. Now let's execute the file. That becomes the descending. Okay. I hope it is clear to all of you. Now, if anyone asks you, what is the practical example of lists? Practically, how do we store what data we are going to store inside the list? Any practical example? So this is the question what an interviewer asked to an employee. Okay, so you can say that a person's data is stored as a list, which can grow or shrink according to the demand. Now, when a person is born, we will store its name, birth date, gender, address, right? After some time, we are going to add it, the PAN card, the Aadhaar number, the driving license, which belongs to that particular person. Okay. If that particular passport expires, then we are going to neglect that particular ID for a time being. Okay. So that's the practical example of the list data structure. So I hope it is clear to all of you. If you have any doubt, please comment. And if you like my video, kindly share and subscribe my channel. Thank you.